Hello everyone, welcome back to Shabest online tutorial. In today's tutorial, we're going to learn how to find the mean and the variance of an exponential distribution using moment generating function. And the exponential distribution, x is distributed exponential exp into parameter theta. And the function is given as what? F of x, which is equal to what? Theta, then e raised to the power of minus theta x, and x is greater than 0. So the moment m sub x of t, which is equal to what? Integral from 0 to positive infinity e raised to the power of tx, and the function f of x is given as what? Theta, then multiplied by exponential raised to the power of minus theta x, then dx. So m sub x of t will be equal to what? Integral from 0 to infinity, then theta. Then we're going to multiply these two together. Since the bases are the same, we write one of the base. If we add the power, it's going to be what? Tx minus theta x, then dx. Then m sub x of t will be equal to what? Integral from 0 to positive infinity, then theta e. So we're going to factor out negative, then we factor out x. It's going to be what? Theta minus t, then x dx. Now we're going to let u to be equal to what? This power, which is what? Theta minus t multiplied by x, so that we have x, which is going to be equal to, we're going to make x the subject of the formula by divide through by theta minus t. So it's going to be what? U over what? Theta minus t. Then if we differentiate x, we're going to have the x now be equal to what? Du all over theta minus t. We're going to substitute the whole of this back to this. We're going to have what? M sub x of t, which is equal to what? Integral from 0 to positive infinity, then theta e raised to the power of minus, then theta minus t x is the same as u. Theta minus t x is the same as u. Replace it as u. Then dx is the same as what? Du over theta minus t. So we're going to have du all over theta minus t. Then m sub x of t will be equal to, we're going to take this out, this constant theta and over theta minus t out. It's going to be what? Theta all over theta minus t. Integral from 0 to positive infinity. This is out already and this is out, so it will remain exponential minus u, then du. But this, we can add u to the power of 1 minus 1, because u to the power of 1 minus 1 is the same as u to the power of 0, which is 1. And when we use 1 to multiply by this is still the same. So that the whole of this is the same as what? Gamma of 1. And gamma of 1 is the same as what? 1. So when this one multiplied by the whole of this, then m sub x of t now will be equal to what? Theta all over what? Theta minus t. This is the same as what? Theta. Then when this one goes up, it's going to be multiplied by what? Theta minus t raised to the power of minus 1, the inverse. So this is equivalent to this. So this is the moment. Now, remember, we are asked to find the mean and the variance. To get the mean, which is what? Is the same as what? Moment at first derivative at t is equal to 0, then sub x. So what is implied is that we are going to differentiate this once, then we substitute at t is equal to 0, then with respect to t, so that we are going to have the mean, which is moment at first derivative of t sub x, which is equal to, if we differentiate it using power rule, minus 1 multiplied by theta is going to give us minus theta. Then we copy this bracket, theta minus t, then raised to the power of minus 1 is minus 2. Multiply by, since we are differentiating with respect to t, when we differentiate this inside bracket, derivative of minus t is the same as what? Minus 1. So that when this minus 1 multiplied by this minus theta, m at first derivative of t sub x now will be equal to, this minus here is going to cancel out this minus, theta, then theta minus t raised to the power of minus 2. And this is the same as what? Theta all over what? Theta minus t square. So this is equivalent to this. So to get the mean, m at first derivative of t is equal to 0. We set t is equal to 0. It's said to be what? Theta all over what? theta minus, in place of t is going to be what? 0, then all square. So this is the same as what? Theta all over theta square, because 0 is the same as 0. 0 square is the same as 0. So when 1 theta cancel 1 theta is going to be what? 1 all over theta. So this is the mean of an exponential distribution using moment generating function. So the second thing we are going to find is the variance. And the variance of an exponential distribution using moment generating function is the same as what? M at second derivative, then we set t to be 0 sub x, minus m at first derivative, then we set t to be 0 sub x, then all square. We have find m at first derivative sub x and t is equal to 0 to be 1 over theta. So all we are going to do is just to square this. So what we are going to look at for is the second derivative and we set t to be equal to 0. So we're going to look for m at second derivative of t sub x, which is equal to, what this implies, we are going to redifferentiate this function. So if you differentiate this function, we're going to have minus 2 multiplied by theta is going to give us minus 2 theta multiplied by theta minus t. Then minus 2 minus 1 is the same as what? Minus 3. Then multiplied by, since we are differentiating with respect to t, is going to be what? Minus 1. So m at second derivative sub x of t will be equal to, this minus is going to cancel out this minus. We have 2 theta into what? Theta minus t raised to the power of what? Minus 3. Then this is the same as what? 2 theta all over theta minus t, then raised to the power of 3. And when we set at second derivatives of x at t is equal to 0, this is going to be what? 2 theta all over theta minus, in place of t is going to be what? 0. Sorry. Is going to be 0, then all to the power of 3. So if we simplify this, we're going to have what? 2 theta all over theta minus 0 is the same as theta, then theta raised to the power of 3. And when this theta cancel one of this theta, this is the same as what? 2 over theta square. So when one of this theta cancel this, so this is the second derivative. Now we're going to substitute back to this variance formula. So therefore, variance of x now will be equal to m at second derivative at t is equal to 0, the same as 2 all over theta square, minus m at first derivative as t is equal to 0 is 1 all over theta, 1 all over theta. But remember, it's all square, so we are going to square this. 1 square, then theta square. So variance of x is equal to what? Theta square, then 1 square is the same as 1. 2 minus 1 is the same as 1. So this is the variance of an exponential distribution using moment generating function 1 all over theta square, and this is the mean 1 all over theta. Thank you for watching, and please subscribe to our channel for more video like this.